Good morning and welcome back to chemistry. I hope you guys had a wonderful weekend. We are in the home stretch of school right before break, and we're also wrapping up Unit 3 today. So I don't know if you guys remember way back at the beginning of Unit 3, we had done these demonstrations in class with hand warmers and cold packs. So we had looked at what were some of the ingredients of these guys. We bust them open. We looked at what was inside. We let them actually react. We looked at the temperatures of them, and maybe you had personal experience with it. And ultimately, we figured out that the hot packs, well, you guys, they get kind of hot, and the cold packs get kind of cold, right? And so, but we're trying to answer the question like, why? How does that actually happen? And so we started this entire investigation that ultimately today is the day that we will be able to answer that question. How do those work? But that investigation started with looking at potential energy in atoms. So I bet like hindsight is 2020, right? Like you're probably thinking back on this and you're like, you know what? That was actually like a lot easier than when we were actually working on it at the time. Or at least hopefully that's how it is for you. But this is review, right? Potential energy in atoms. We had a graph that looked like this. The y-axis here represents the amount of potential energy. And I want to point out that this line here represents zero, which means the atoms have no potential energy. That was one of the most commonly missed questions on our exit slips was people thought that this line represented like low potential energy. And it's not. This line here represents zero. So when atoms are super duper far apart, the potential energy of those atoms is pretty much zero. They're not interacting at all. Now, as those atoms get closer and closer, what we start to see is the two atoms start to attract each other. The negative electrons of one atom are attracted to the positive nucleus of the other atom. Now, once that attraction starts happening, notice what happens to the potential energy. It starts to go down away from zero, right? It starts to go down, and eventually we get to this lowest possible point. That is when potential energy is at its lowest. Now, a couple things are happening here that are like key characteristics you have to remember. When potential energy is at its lowest, that means that the forces of attraction and repulsion are balanced between the atoms. So, yes, the electrons are being attracted to the nucleus, but at the same time, there's the nucleus repelling the nucleus. Now, when those forces are balanced, right, that's this point here. This is the most stable point for these atoms. At this point, this is where we're going to see bonding happen, right? Now, the atoms don't just like stop there and say, oh, this is exactly where things are supposed to be. We're just going to stop here and be happy. Like that doesn't happen. Atoms will continue to move. In fact, they will move a little bit closer. And as they move closer, then the atomic nuclei get too close. They start to repel each other. And notice what happens to the potential energy there. It spikes, right? And when it becomes this high, very unstable again. Now, let's backtrack a little bit. Let's come back to this part of the graph when we say this is the most stable. This is when atoms are going to bond. We talked about, oh no, where did I put it? Two types of bonds. Here we go. We talked about ionic bonding and covalent bonding, right? The main idea with both of these is just that having an octet lowers your potential energy, right? So when we get to this point in our graph, these atoms are going to either start transferring their electrons or they're going to start sharing their electrons based on their needs, all right? Now, the next part of our review, we were talking about, okay, we know bonds are going to be created when potential energy is at its lowest, when attractive and repulsive forces are balanced. But what exactly else do we need to know about the formation of those bonds? We talked about how potential energy is converted to kinetic energy. And that was kind of like this chunk of the graph right in here. As soon as we start to see that force of attraction come into play between atoms, that potential energy is being transformed into kinetic energy. But if we were to just have like two atoms all by themselves, like in its own system, those atoms wouldn't be able to maintain the bond that they're trying to create because they have too much kinetic energy. So what happens is we rely on other atoms within the system, within the environment, that we can kind of bounce off of and transfer some of that kinetic energy. It lowers the kinetic energy of the atoms trying to bond, and thus they can actually hold their bond. So if you think about it, right, in everyday life, there's millions, billions, quadrillions of atoms around. So it's not a rarity to have a third atom around that you can bump into to, like shed off some of your extra kinetic energy. That's like a normal thing, right? That's why chemical reactions happen all the time. So the main idea with forming bonds, though, we have to remember that energy is released when a bond forms. And you think about it, yeah, some of the kinetic energy is given off to surrounding atoms, lowers the kinetic energy of the bonding atoms, so we can actually maintain a bond. That's why we say energy is released when a bond forms. Now let's think about the opposite scenario. What about when we want to break a bond? So maybe you remember this simulation where we had atoms that were bonded together and we had to like shoot a third atom at it. And the trick was that that third atom has to have enough kinetic energy that when it hits or like bumps into those bonded atoms, it will transfer some of that kinetic energy to that molecule. Now, when that kinetic energy is transferred to that molecule, it's the exact opposite of what we were doing when we were forming bonds. That molecule will have too much kinetic energy, the bond will break, and that's the end of that scenario. So the big idea there, energy is absorbed when a bond is broken. You have to think back and say, yeah, the bonded atoms have to absorb some of that extra kinetic energy from another atom in the system. If it absorbs that extra kinetic energy, bumps their energy up, they have to break because they're unstable, right? So we're going to take those ideas back with us when we talk about hot packs and cold packs. Specifically looking at whether or not those reactions are, and some of you mentioned this before, exothermic or endothermic. Before we officially get into that stuff, I want to do a very quick review. Some of you may know this, some of you may not. When we write chemical reactions, we always write them with this arrow in the middle, which means we are starting with some compounds here and we're ending with some other compounds. Now, we call the atoms that we're the molecules that we're starting with reactants. These are the things that we are reacting together, right? The things that we end with, we call them the products. Now, what does that mean for us in terms of forming and breaking bonds? Reactants are always broken apart, right? If these were like Lego pieces here, I would need to break these guys apart in order to form my final products over here. It's important to note the law of conservation of mass, that the kind of atoms we are starting with in the reactants, along with the amount that we're starting with, is the same as the kind of atoms that we end with, along with the amount, right? So we're going to take all of that knowledge with us as we try to answer this question. What is the relationship between energy and breaking and forming bonds, and deciding if a reaction is exothermic or endothermic? So what you guys will do next, you will watch a, actually I could just show you in this video. Let's do that. Oh no, you can see all my tabs. Actually, maybe you can't see all my tabs. Okay, you're going to watch another video that introduces and kind of guides you through what you need to do for the POGIL Model 1. So watch that video next.